Due to popular opinion, a lot of people have been asking that, sir, please touch bisection method. So my number remains 09058669385. All right, you are speaking with Sir Rizzy. All right, this is numerical analysis anyway. Want to solve that same. How many of you remember that question yesterday? We're trying to solve this question: x raised to the power of 3 minus 6x plus 4 is equal to 0. It says solve this, solve this particular question. Remember yesterday I used what we call the Newton-Raphson's method to solve this problem. The Newton-Raphson's method, where I said xn plus 1 is equal to xn minus f of xn divided by the differential f prime of xn. But now we're not doing that today. We're not doing that today, We are doing something very, very interesting. Something very, very, very interesting. So I want you to pay very close attention. So first of all, you're going to find the interval of operation. So first, you do what? You find the interval of operation. You find the interval of operation. Is that not? Let us find the interval of operation. Okay, so you quickly come to your calculator. You come to your calculator and you write something like the question itself: x to the power of 3 to the power of 3, right, minus 6x plus 4. So we are calculating at 0. We're starting with 0. If you calc at 0, that's 4. So let's just put it like this. We write x, we write f of x. At 0, you have 4. At 1, you have minus 1. So these two people prove Descartes' law. These two people prove Descartes' law because f of 0, when multiplied by f of 1, the answer is 4 times minus 1, which is equal to minus 4. And minus 4 is less than 0. So Descartes' law have been proved. Let's not forget that Descartes' law says f of a multiplied by f of b must be less than 0. Interesting. Very, very interesting. So the bisection method. Now that we have been able to ascertain the interval of operation that we'll be working with, it means the root lies between 0 and 1. The root lies between 0 and 1. Bisection method. Very interesting. So now that you have been able to find the root of operation, it is time for you to dive into the question. And so on your calculator, let me write it here. Note that on the calculator, on your calculator, what you'll be doing there is you say x is equal to a plus b divided by 2. Is that okay? And then you write the equation itself. Is that okay? That's what you are going to write on your calculator. So let's quickly do that. You come to our calculator and write, you say alpha x is equal to, now some of you don't know how to write the equal to is alpha calc, alpha and calc, calculator sign. So you press this, you write alpha a plus alpha b, and then you divide by 2, and then you write alpha integral sign. The equation is x to the power of 3, alpha x to the power of 3, is that not, minus 6x plus 4. That's an interesting one. That's a very interesting one. Alpha x to the power of 3 minus 6x plus 4. So you go back to the question. Now you draw a tabular form, right? You write iteration, the number of iteration you want to do, your a, your f of a, your b, your f of b, your c. See, this is where the bisection happens. A plus b over 2 is where an f of c. So at my first iteration, look at what I'm about to do. At my first iteration, my a was, this is our a root lies between a and b. So my a now is 0. What is my f of a? Who can tell me? My f of a is 4. Look at it. My f of a is 4. What is my b? My b is 1. My f of b is minus 1. My b is 1. My f of b is minus 1. So what will be my c? What will be my c? A plus b over 2, right? So you come to your calculator and press, after writing this in your calculator, you press calc at a. A is 0, b is 1. So your a plus b over 2 is 0.5. So you come here and write 0.5. Come here and write 0.5. What is your f of c? Your f of c now, you now write equal to again. Your f of c is 1.125. So you write 1.125. Do you understand? Now, look at these figures very well. This is a positive, this is a negative. So this is a newborn baby born. These are the newborn babies. These are the newly born babies. So at your second iteration, you bring back that newborn baby into this column as your A. As your second iteration, you write 0.5. That's your newborn baby now. This new child that you just gave birth to, 0.5 here. You bring it back here. Now you are going to ask yourself, what is f of 0.5, right? F of 0.5 is this particular person, right? 1.125. 1.125. Then what will be your b? The question now will be what? What will be your b? So this person has to happen to be a positive figure, right? This person, so you are going to tally it with a negative figure. So who was the last person to give you a negative? B. Because f of b is minus 1. That's a negative figure. Is that not? As a what? A negative figure. So at this point, my b now will be what? 1 again. Alright? My f of b will be minus 1. So what will be this? So calc at 0.5. Okay, calc at 0.5, calc at 1. See that? So a over b plus 2 is 0.75. This one is minus 0.078. Minus this one is 0.75. This one is minus 0.078. I want you to pay attention to this pattern. If you pay attention to this pattern, you will get it. Now you come back to this place. At your third iteration now, you are coming to third iteration 3. Who will be your A? Your A is this newborn baby that you just gave birth to. Yeah, you bring this back. That's 0.75. Do you understand me? What is your F of A? This is your F of A. It is minus 0.078. I believe you are smart enough. You already understand what I'm doing. Yes. So what will be your B? You ask yourself, if this person was negative, and you need to marry, because Descartes' law, let's not forget, Descartes' law says f of a, when multiplied by f of b, must be less than 0. So we need one negative and one positive. Do you understand me? Because minus times minus is a plus, so that's wrong. Plus times plus is a plus, so that's wrong. So you need for you to have something less than 0, you need a negative should multiply a positive, so that you have negative. All negative integers, minus 1, minus 2, minus 3, all negative integers are less than 0. Is that not? So that is the baseline of my argument. Do you understand? That is the what? That is the baseline of my argument. So if you come back here, you ask yourself, okay, so if this is a negative figure, then I need another person. Sorry, I need somebody that will give me a positive. Who was the last person to give us a positive? Who was the last person to give us a positive? We'll find out that it's this man. Abi? 0.5. Because look at it here. A was 0.5. F of A was 1.2. So this is a positive. So you now come here and write your B will be 0.5. Your F of B will be 1.125. So what is your C? Is that C? You go back to your calculator and press. You say calc at, what is our new A? Our new A is 0.75. Our new B is 0.5. 0.5. 0.75, 0.5, bam, bam, 0.625, 0.625, 0.625. Did you see that? You understand me now? So our f of c now will be 0.494, 0.494, 0.494. Now don't panic. If you were given this in the exam, you'd have just solved it this way. They will mark it for you. It's very interesting. You know, if you were given, they say solve by bisection method. Immediately you see bisection method there, just do it like this. so that you don't consume too much of space. You understand? And you make sense like that. At your fourth iteration, you see that at the fourth iteration, you bring back the newborn babies 0.625, 0.625. What is f of 0.625? 0.494. So it's time for marriage now. This is a positive figure. I need to pair it with a negative, I mean. So who was the last person to give me a negative figure? Who was the last person to give me a negative? This guy, 0.75. Because look at the negative here. You see the negative. So 0.75 will be here, 0.75. F of b will be what? Minus 0.078. So let's go back and write 0. Sorry, let me check that figure again. A is what? 0.625. 0.625. So come here and write A is 0.625. Okay, calc for me at 0.625. There is a mistake, sorry. So back to what I was doing. So our A is 0.625, our B is 0.75. So you come here, A, calc for me at A 0.625, B 0.75. Our A plus B over 2 is 0.6875. 0.6875. 0.6875. Then our F of C. What will be our F of C? Our F of C is 0.199. 0.199. So I come here. 0.199. You see, I don't even need to write 0.199. I just need to write that it is a positive figure. I don't need that value there. So I come here and write number 5. Watch what I'll do at step 5. Now the newborn baby is 0.6875. 0.6875. F of A is a positive figure, so I don't need it. I just need that. I just need the fact that it is a positive or a negative. F of B. So who gave me the last negative figure? Who was the last negative figure I have? The last negative figure is this guy, because F of this guy is a negative. So this is a 0.75. You can see that F of this guy is a negative, so I don't need to. I just need to come to my calculator and write calc at 0.6875. Calc at 0.75. Okay, the middle ground is 0.71875. 0.71875. 0.71875. And F of C will be what? What will be F of C? That will be 0.05. That's a positive figure. That's a positive figure. You see why I'm not stressing? How am I'm not stressing myself? Good. So at the 6th iteration, I'll bring this newborn baby back 0.71875. Okay, that guy happened to be a positive figure. I'm going to pair it with a negative. Who was my last negative figure? This guy, 0.75. It's a negative figure, so I just need to put minus there. So I want to believe that you understand what I'm doing. I want to believe 0.71875. 0.75. Calc at 0.71875. 0.75. The middle ground is 0.343. 0.343. 0.7343. Is that not? Let's check that. And the F of the middle ground is what? Minus a negative figure. Bam. All the F's. Just be checking the signs of all the F's. Now at iteration 7, I bring this newborn baby. here and write 0.7343. It's a negative figure. Who was the last person to give me a positive? This guy is here. Have we? That's a 7. Sorry. 0.71875 is a positive figure. What will be the middle ground? Let's check. 7343 71875 7343. Let's check. Calcat 0.7343. Let me confirm that. 7343 0.71875 0.71875. Middle ground is 0.7265. 0.7265. What is the F of the middle ground? A positive figure. I put it as positive. Did you see? So in the end, at 7th iteration, I'm having 0.7265. I think when we're using this Rasmussen method, we have 0.7321, something like that. Let's keep doing. Let's see. At the 8th iteration, let's see, the newborn baby is 0.7265. The F of that guy is a positive. So I need to pair it with the last person that gave me a negative, this guy. So 0.7343 is a negative. One negative, one positive, one negative, one positive, one negative, 0.7265. Calcat 0.7265. Another one is 0.7343. 0.7343. Pam 0.7304. 0.7304. That's a positive figure. I just need to put a positive. We're getting closer. At the 9th iteration, bring the newborn baby back. 7304. A positive. Who was the last person to give us a negative? 0.7343. Negative. So let's do this one. Calcat. What is the value of A? 0.7304. 0.7304. Calcat B 0.7343. 0.7343. Middle ground is 0.732. 7324 or 7324. Yes, 0.7324. Was it a negative? F of it is a negative. That's a negative. Wow, bisection method is a lot though. Bisection method. So at the 10th iteration, let me bring this 0.7324, a negative. Who was the last person to give me a positive? 0.7304, positive figure. So let me do that again. 0.7324. Calcat 0.7324. B 0.7304. 0.7304. Pam 0.7314 and a positive. 0.7314 and a positive. Okay, let me do it to the 11th time and see. 11. Bring that newborn baby here. 0.7314, a positive figure. Who was the last person to give me a negative? This guy. 0.7324, a negative. So who is, let's go. Calcat 0.7314 and 0.7324. 0.7324. 0.7319. 0.7319. 0.7319. F of it is a positive. Okay, it's a positive. So if you have gotten to 10 and 11 and you discover that the answers are not repeating each other, you can just as well just add like 3 numbers and divide it by 3. So to get the root, let me just find the average of 3 numbers here out of the, so let me just do 0. Normally I'm supposed to continue until the next number is the same thing, until this one is the same thing as this one, until the next number I will get is the same thing as the previous number. Do you understand? Let's just get the average here. 319 plus 0.7314 plus 0.7324. Let's divide it by 3. Let's just stand at the point. 0.7319. Let's do that quickly. 0.7319 plus 0. What's that? 0.7314. 0.7314 plus, what's that? 0.7324. 0.7324. What's our answer? Our answer is 2.1957 divided by 3. How many figures do I have? 3. Divided by 3. Our answer is 0.7319. Let's just stop there. 0.7319. See that? But what is it called? When we use the RIZZY'S method, it gave us 0.7321. So it's very close, right? So that is how to use the bisection method. Now let's use a calculator trick on RIZZY'S method. Let's do the calculator trick on RIZZY'S method. On the same question, right? Let's do it on the same question. The question says x to the power of 3 minus 6x plus 4. X to the power of 3 minus 6x plus 4. Let's do the same thing. We'll find interval of operation on a normal day. Interval of operation is the normal interval of operation you always get, 0 and 1, by trial and error, right? So let's do that quickly. What's the differential of this function? Let's differentiate this function. 3x squared minus 6x. So in Newton-Raphson's case, Newton-Raphson tells you that you write what? It says you write x, a big X, minus the equation itself, x to the power of 3 minus 6x plus 4, and then divided by the differential. That's 3x squared, abi? 3x squared minus 6. See that? So let's calc at the middle ground. You know, I said in the RIZZY'S method now, let me choose a convenient x naught. So here we'll say, okay, let x naught be 0 plus 1 divided by 2. Let's say 0.5 at the middle ground, 0.5. So let's go. Calc at 0.5. The answer is 0.71. That means x1 is 0.71. What the fuck did I write there? 7142. 714285 or thereabout. Okay. Then what will be x2? You just simply tell it to calc at ans. Calc at ans. 0.3189. 0.73189. Right? 0.73189. Okay. Then you tell it to calc at ans. Calc at answer, the previous answer, 0.7321. You see? x3, 0.7321. Because you have 205 there, approximately 0.7321. x4, calc at ans. Calc at the previous answer, 0.7321. So you see, 0.7321. You see, by Newton-Raphson's method, the solution to this equation, the root, by Newton-Raphson's method, see that, is 0.7321. Which brings me to something. One of you asked me to solve finding the square root of a positive integer. Finding the square root by NR method. By Newton-Raphson's method. Newton-Raphson's method means NR. Please let me write it too. Newton-Raphson's method is called NR method. Finding the square root of a positive integer using NR method. So you say let x is equal to the square root of n. So let's square both sides. Let's square both sides. That's x squared is equal to n all squared. This two will cancel this. You have x squared is equal to n. So if you turn it to an equation, you have x squared minus n is equal to 0. So you differentiate the function. Differentiate the function. If you differentiate the equation, you're going to have x. Now you're going to have 2x. Yes, 2x. Now add n here, telling us that they are element of all natural numbers, n. So Newton-Raphson's method, remember, xn plus 1 is equal to xn minus f of xn all over f prime of xn. That's Newton-Raphson's formula. So we are saying that xn plus 1. So before you write that, let your f of xn be your equation. This equation that you got here, which is x squared minus n. And let your f prime of xn be the differential that you got here, which is 2xn. Anywhere you see x squared, just put n for me. Put n, suggesting that the element of natural numbers. So we have xn plus 1 is equal to xn minus, what is your f of xn? X squared minus n divided by, what is the differential of this? Your differential is 2xn. So 1 times 2xn, 1 in this is 2xn, this is 2xn squared minus, we're doing LCM right now, this in this is 1 multiplied by this, you have this. So this will now be 2xn squared minus x squared n plus n, put an n here please, divided by 2xn. So your answer is xn squared plus n divided by 2xn. So this is the Newton-Raphson's iterative formula for finding the square root of positive integer. I believe I've taught this before, for finding the square root of positive. Then let's talk about the Newton-Raphson's iterative formula for finding the cubed root of a positive integer. We have let x equals to n cubed root of n. Abi, take the cubed of both sides. Abi, take the cubed root of both sides. We have, okay, no, don't take the cube, not take the cubed root, take the cube of both sides, equals to n raised to the power 1 over 3, take the cubed. So we have x to the power of 3, this cancels this, is equal to n. So we have x to the power of 3 minus n is equal to 0. You are turning to an equation here, right? So let's differentiate this function. Differentiate the function with respect to who? With respect to x. That's 3x squared. So when it's 3x squared, you now say, okay, what do you do when it is 3x squared? You now say, remember that xn plus 1, the Newton-Raphson's law, xn minus f of xn all over f prime of xn, right? So this now be telling you that what xn plus 1 is equal to xn minus, what is f of xn? This guy, the equation itself, x cubed minus n. What is f prime of xn? 3x squared. 3x squared. Please, anywhere you see n, just put n so that everything will rhyme. So find the LCM of this. 3x squared n. 1 in 3x squared n, that's 3x squared n times this one is cubed, minus 1 in 3 in 3, that's 1 now. This is 2x cubed n plus n divided by 3x squared n. All right, that's that about that. That is the finding the cube root of a function using Newton-Raphson's method. Oh, now they can ask you to use this particular thing to find the cube root of 24. You know, find the cube root of, what you're going to do is that you're going to say, what is the, first of all, what is the cube root of, let's go back to this. Let's assume that it says, now that you have gotten it now, find the cube root of 24. What is the cube root of 24 on a normal day? The cube root of 24 that's 2.884. Cube root of 24 is 2.884 on a normal day. So you are going to pick the whole number. You pick the whole number there, which is 2. That's the whole number there. So your x naught, let x naught be 2. So I'm going to write this particular thing now. I'm going to write it on your calculator. 2x cubed plus 20. And n, note that let n, your n is 24. So 2x cubed plus 24 divided by 3x squared. So a fraction sign, 2x cubed plus 24 plus 24 divided by 3 alpha x squared. So calcat 2. If you calcat 2, you're gonna have what, 3.333 at 2. So x1 is 3.33 whatever. x2, calcat answer your previous answer, 2.942 x3, calcat answer 2.885 x4, calcat answer 2.884 x5, calcat answer 2.884 again, and it has repeated itself, 2.884. So it has repeated itself. The fact that it has repeated itself makes us know that it's the answer. Normally on a normal day, what is the square root of 24? Cube root of 24, 2.884. So our answer, so at x5, our answer is what, 2.884. You go home. So first of all, I want to wish you the best in your examination. I want to wish you the best in your what? In your examination. I want to wish you the best. It's a privilege to have worked with me by Sir Rizzy. Sir Rizzy, our number is 09058 all over the world 9385 plus 2349058669385. You can DM us on WhatsApp. Right? It's an interesting time to be with us. We love you. We cherish you. Don't forget your errors, right? In your errors, we talked about errors. We said is the true value minus the approximate, right? Another thing we talked about was our absolute error. Don't forget, we said absolute error is true value, still the same thing, but in the absolute bracket, and as the approximate value. We talked about relative error. Relative error is absolute error over exact value. Let's not forget that. We talked about transcendental functions. Transcendental functions, where we're able to talk about the bisection method. I just treated that right now. The bisection method, the fixed point method, and the what? We talked about the regular Fauci method. Regular Fauci, we talked about Newton-Raphson method. All these were there. And then we moved to what we call the shift operators. Shift operators, where we talked about forward difference of y naught is y1 minus y naught. If I say forward difference squared of y naught, what is it going to be? It will now tell me this, right? Which is the same thing as forward difference of y1 minus y naught. So forward difference of y1 minus forward difference of y naught is the same thing as y2 minus y1 minus y1 minus y naught, which is y2 minus 2y1 plus y naught. We treated this. We said what's the relationship between this and this. They are all on our YouTube page, right? What's the relationship between this and this? It's all there. Please visit our YouTube page for more. Thank you and God bless. Amen.